Hello and welcome friends. In this video we are going to derive the equations of kinematics by using calculus. So without wasting any more time, let's get right in. Now let us consider a particle which has been moving with an uniform acceleration a. So by definition what we can write is acceleration is equal to dv by dt, where v stands for velocity and t stands for time. Now we will take dt in the left hand side is equal to dv. Now integrating both sides, a dt is equal to dv. Here we are going to set the lower limits as 0 seconds and the upper limit as t seconds. And same here, we are going to set the lower limit as u, which is the initial velocity, and upper limit as v, that is the final velocity. So now let's look. Since a is constant, a is going to come out, and the integral of dt is t from 0 to t seconds is equal to the derivative, the integral of dv is equal to v. So we will write v here, and its lower limit is u and upper limit is v. So a t minus 0, once we are going to put the t upper limit, then we are going to subtract the lower limit from that, is equal to v minus u. So finally we have is a t is equal to v minus u, implies v is equal to u plus a t. This is the first equation of motion. Till now we have proved the first equation of motion, that is v is equal to u plus at. Now we are going to prove the second equation of motion. So for that we are going to use velocity is equal to ds by dt, where s represents distance. So we are going to put the dt in the left hand side. V dt is equal to ds is equal to or implies. Now what I am going to do is, in place of this v, I am going to put u plus at, because v is equal to u plus at from the first equation of motion. U plus at by d multiplied by dt is equal to ds. Now we will integrate both these sides from 0 seconds to t seconds. U plus at multiplied by dt is equal to from 0 to s ds, implies integration from 0 to t seconds u dt plus a t. So I am going to integrate here I dt multiplied by dt, is equal to, now the integral of ds is equal to s. Now since u is constant here, so it is going to come out, and the derivative of the integral of dt is equal to t. So lower limit is 0 and upper limit is t, plus now a is constant here again, so it will come out. Now the integral of t is t square by 2 from 0 to t. Integral of t is t square by 2 is equal to s minus 0. Implies u t minus 0 plus a t square by 2 minus 0 is equal to s, which implies ut plus half a t square is equal to s. Implies s is equal to ut plus half a t square. So this is the second equation of motion. Now you have seen how we proved the first equation of motion and second equation of motion. Now let us prove the third equation of motion, that is v square is equal to u square plus twice as. For that we are going to consider again acceleration is equal to dv by dt. Now this part is a little tricky, so please look attentively. So dv by dt, now we are going to multiply with ds and divide it by ds. These two are going to cut and we are going to get 1. You will see after some time why we did that. Now acceleration is equal to dv. What I am going to do is I am going to bring this ds here into ds by dt. I have brought this t here. Implies acceleration is equal to dv by ds into phi, because by definition phi is equal to ds by dt. Implies, now we are going to take this ds to the left hand side. A ds is equal to v d phi. Now integrating both the sides from 0 to s, a d s, and here also from u to v, it is initial velocity to final velocity, phi d phi. Now this implies acceleration is constant here, so it will come out, and the integral of ds is s from 0 to s is equal to, now the integral of v is v square by 2 u to v, initial velocity, final velocity. Now a s minus 0, once we are going to put the upper limit, then we are going to subtract the lower limit. Same as here, phi square by 2 minus u square by 2 . Now as is equal to half phi square minus u square. Implies twice as is equal to phi square minus u square. I have taken this 2 in the left hand side. So phi square is equal to u square plus twice as. So here we have the third equation of motion. Thank you all for watching. If you have any suggestions, please comment down below. Please like to encourage us. Till then, goodbye.